Hello students, welcome back to Physics with Ashwini. In today's session, we are going to discuss one of the most important and frequently asked concepts in physics, as you can see on the board, conservation of linear momentum. This principle is not just theoretical, it also plays a crucial role in understanding the real life phenomena like collisions, recoil of a gun, and motion of the connected bodies. Along with the concept, we will also solve some of the previous year questions from the NEET exam so that you can clearly understand and how this topic is tested and how to approach problems effectively. So stay focused till the end because this session will definitely boost your confidence for exams. So let's get started. What is linear momentum basically? Linear momentum. Linear momentum is simply the product of mass and velocity, right? It's a product of mass and velocity. So linear momentum P is nothing but m into v, and this is a vector quantity. Conservation. What do you mean by conservation? Conservation means no change. That means something is remaining constant. So whenever I say conservation of linear momentum, it means the linear momentum is remaining constant here. So for example, you consider any example like firing of a gun, bullets are ejected from the gun, and taking a collision of between two objects. So any such example. So if you consider any process, before the process and after the process, the linear momentum remains the same. And always remember, we have to take the system as a whole. So system's initial momentum will be equal to system's final momentum. That is the meaning of conservation of momentum. So the whole system initial momentum will be equal to whole system final momentum. Let's write this in this way. So momentum initial for the whole system will be equal to momentum final for the whole system. So as a whole, for the whole system, initial momentum and final momentum will be same. And this is called conservation of linear momentum. Tell me one thing, if momentum remains constant, so if P is remaining constant, what will be the change in momentum? Change in momentum with respect to time. This will be zero, right? Because there is no change, momentum remains the constant. So according to Newton's second law, now what is the force? Force will also be zero. Because what is Newton's second law? Just recollect, it's the rate of change of momentum, right? So momentum change is zero, so force is also zero. So remember this point as well. So this is the important point. The momentum of the system before a process and after a process remains the same, and you have to consider the system as a whole. Clear? So just remember this. And what is the momentum formula? M into V. So if you are done, then we will do some previous year questions from your NEET exam. Fine. Let's see this question now. See, such a simple concept, but there are many PYQs from your NEET exam, and we will do one by one. An object flying in the air with the velocity. So what is the initial velocity? It is 20I plus 25J minus 12K. Suddenly breaks into two pieces. So imagine this is an object which is flying in the air with that initial velocity. Now it was broken into two pieces. Let the first piece be this, whose masses are in the ratio 1:5. That means if I assume this as 1 kg, what will be the mass of the second piece? It will be 5 kg. Now can you predict what is the total mass of the object now? It is 6 kg. The smaller mass flies off with velocity. So this is the velocity of the smaller mass. This is the smaller mass, right? What is its velocity? This is 100I plus 35J plus 8K. The velocity of the larger piece will be. So you have to find the velocity of the larger piece. Very simple. So just apply the conservation of linear momentum. What is conservation of linear momentum? You have to take the system as a whole. So initial momentum of the system is equals to final momentum of the system. So initially the smaller mass, heavier mass, there was no such case. It was together as one object. So that object mass is 6 kg. And what is the velocity initially? 20I plus 25j minus 12k. Did you get how did I write this? Momentum formula is what? It's nothing but m into v, right? So initial mass is 6, initial velocity is this. Now finally, final momentum. In the system there are two pieces now. So you have to take the momentum of first piece, also the momentum of second piece, and you have to take their addition. So m, that is 1, v is 100i plus 35j plus 8k. This is the momentum of the smaller mass. Plus, what is the momentum of the larger mass? M into v. We don't know that, so keep it as v only. Now just simplify this, you will get the answer. So 120i, it is 150j, 72k. This is equals to 100i plus 35j plus 8k plus 5 into v. So take the subject of 5v. Now what will you get? 120i minus 100i, you will get 20i. Now 150j minus 35j, how much will you get? 150 minus 30, it is 120. Again one more 5 minus, so 115j. Minus 72 minus 8k, how much will you get? Minus 80k. So this implies v is equals to, divide with the 5, what will you get? 5 4s 20, 5 2s 10, and 5 3s 15, 5 1s 5, and 5 6 30. So what is the velocity now? 4i plus 23j minus 16k. So this is the velocity of the larger mass. 4i 23j minus 16k. So this is in option A. Any difficulty? So just remember this concept. For the whole system, the linear momentum remains conserved. Initial momentum is equals to final momentum. Now, see this question. An explosion breaks a rock into 3 parts. That means before the explosion, the rock's velocity is 0. After the explosion, there are 3 parts, fine. So 2 of them go off at right angles to each other. So let this be the rock. It was broken into how many parts? 3 parts. So 2 of them are going at right angles. So let's do one thing. Angle is how much? 90 degrees. Okay. The first part of mass 1 kg. So let this be the first part, mass 1 kg. What is its velocity? It is moving with 12 meter per second. And the second part of mass 2 kg moving with 8 meter per second. So second part mass is 2 kg and its speed is 8 meter per second. If the third part flies off with 4 meter per second, then its mass. So third part mass we have to find. Its speed is given, but you have to find its mass. Now tell me, if the 2 pieces are going at right angles to each other, what will be the direction of the third part? See, before the explosion, the initial velocity is 0. So the initial momentum of the whole system is 0. That means the final momentum of the whole system also must be 0, because that is the conservation of linear momentum, right? If the initial momentum of the system is 0, then final momentum of the whole system also must be 0. But if you take final, part of the system, there are 2 parts and there is also third part. So 2 are going at right angles and they are having masses, they are having velocities. So how the whole system final momentum becomes 0? Such that if you take their addition, if momentum is a vector quantity, if you take their vector addition, then it must come out to be 0. So to do so, what happens here? This is the resultant of the 2 parts, right? This is the direction of resultant momentum of 1 kg and 2 kg. So exactly in opposite direction is the moment of the third part. So this is the direction of the third part. And how do you say that that is the direction? Because the system's final momentum also have to be 0. If you take the resultant of first 2 parts, this is the direction, and third part must be in exactly opposite direction, so that the vector addition of momentum becomes 0. Got this point? This problem is important because same model only the data is different, question is same, only just the numbers are different, and this kind of question is repeated for more than 3 times. So remember this. Okay, now let us simplify this third part. Velocity is given 4 meter per second. You have to find out its mass. First of all, what is the resultant of the first 2 parts? What is the momentum here? M into V, that means you will get 12. What is the momentum here? 2 into 8, you will get 16. And what is the resultant of these momentums? It is 12 square plus 16 square. How much will you get? 12 square is 144 and 16 square is 256. How much will you get? 144 plus 256, it's 400. Okay, that means it is 2020. So this is the resultant momentum. Now if you see the diagram, this resultant momentum is equals to momentum of the third part. So momentum of the third part must be equal to what? Resultant momentum. So M, we don't know the mass of the third part. V is 4. Resultant momentum is 20. So what is the mass of the third part now? It is 20 upon 4. So this is 5 kg. So what is the answer now? Option D. Is this clear? Important. Same model is repeated for more than 3 times. 2 parts will fly away at perpendicular, at 90 degrees angle. Then what is the velocity of the third part, or what is the mass of the third part? Same model. So just practice this once again. Okay. We'll see one more question. A person holding a rifle, mass of the person and the rifle together is 100 kg. Fine. So person along with the rifle. What is the mass? It is 100 kg. Stands on a smooth surface and fires 10 shots horizontally in 5 seconds. So in a time of 5 seconds, how many shots are fired? 10. That means 10 bullets are fired actually. What is the each bullet mass? It is 10 grams. So each bullet, mass of each bullet is 10 grams. So can I write it as 10 by 1000 kg? Next, with the muzzle velocity, what is the velocity of each bullet? It is 800 meter per second. The final velocity acquired by the person and the average force exerted on the person. That means, see, imagine, this is a practical thing. If you imagine, it will be very easy to understand. Imagine you are firing a bullet from a gun. So the bullet moves forward with some velocity v. Don't you think the hand holding the gun faces a jerk in the backward direction? Yes or no? We face a jerk in backward direction. So let that velocity be v2 here. Bullet velocity is v1. The velocity of the jerk we are feeling is v2. So that is what the question is asking. What is the final velocity acquired by the person? What velocity will the person acquire? It's nothing but the jerk, right? So you have to find the jerk velocity v2. So how shall we do this? Let this be m1 and let this mass be m2. So initially bullet is not fired. So the whole system initial momentum is 0. The whole system's initial momentum is 0. That means the person and the bullet together, person and the bullet together, that's the system. So system's initial momentum is 0. So according to conservation of momentum, now final momentum of the whole system also must be 0. So what is the final momentum here? The momentum of the person and the momentum of the bullet. So this summation must be 0. When this will be 0? If they are moving in opposite direction. If the bullet moves forward, the person feels a jerk in backward direction. So I can say now m1 v1 must be equal to m2 v2. Because the final momentum of the system have to be 0. That means their momentum must be in opposite direction. So what is m1 here? 10 grams. So 10 upon 1000 because we have to take it in kilograms. Speed is what? 800. What is m2? 100. What is v2? That means the final velocity of the person. We don't know. So just keep it as v2 only. Now simplify this. What gets cancelled? 2 zeros cancel. 1 0 1 0 cancel. So what is V2 now? It is 8 upon 100. So this is equals to 0.08 meter per second. So 0.08 minus, why is it so? Because if you see V2, if bullet is moving forward, what is the direction of V2? It is in opposite direction. So minus. And there is only one such option, that is option A. But we will do the next question also, average force exerted on the person. But if you see the options in exam, to save the time, if there are two questions, if your answer for the first question is given only in one option, then directly you can go for it. No need to waste the time. But this is a class, so I'll just tell you the concept for the second question also. Clear with this first answer? What is the velocity acquired by the person? It's nothing but 0.08. Now we'll find out the average force on the person. How will you find the average force exerted on the person? That is nothing but the rate of change of momentum, right? Now, how many bullets are shot? 10 bullets are shot. So take that number of bullets also, because every bullet will create some impact, right? So when you are taking the average force, take the total number of bullets into consideration. What is change in momentum? Momentum is m into v. What is change in momentum? It is m into change in velocity, v minus u. So they are asking average force on the person. So what is the person's initial velocity? 0. What is the person's final velocity? 0.08. So just substitute now. Mass is 100. Final velocity 0.08. Initial velocity 0. Time, what is the time given? Time is 5 seconds. 5 seconds is the time given. So 5 seconds, and number of bullets is 10. So just simplify this. How much do you get? So 2 decimals and 2 zeros cancel. So you'll get 8 by 5 into 10. So 5 one time, 5 two times. So 8 into 2. So this is 16 newtons. So how much is the force exerted? It is 16 newtons. So 16 newtons. Again, this is in option A. Clear? Fine. See this question. An explosion blows a rock into 3 parts. 2 parts go off at right angles to each other, and these two are 1 kg first part moving with this speed, 2 kg is the second part and moving with this speed. So the third part flies with this velocity. What should be its mass? It's the same question that I told you. So this is a rock initially at rest, so its initial velocity is 0. So the whole system initial momentum is also 0. Now according to conservation of linear momentum, the final momentum of the system also must be 0. That means momentum of the first part, momentum of the second part plus momentum of the third part must be 0. And it was given the first part and second part, they are moving at right angles. So first part is 1 kg, its speed is 12 meter per second. Second part is 2 kg and it is moving with 8 meter per second. What is the resultant of these two? First part and second part. They are at right angles. So this is the resultant momentum, right, of the two parts. So where will be the third part now? Exactly opposite to this resultant. This is the direction of the third part. So third part speed is given 4 meter per second. You have to find its mass. So very simple. So you have to take the vector sum because momentum is a vector. So P1 plus P2, it's nothing but resultant. Plus P3 must be equal to 0. That means this resultant and P3, they must be in opposite directions. So first find out what is the resultant momentum. M into V. So this is 12. M into V. So this is 16. So what is the resultant? They are at 90 degrees. So 12 square plus 16 square. See, the data is also not changed. So 12 square plus 16 square, you will get root 400. So that means 20 Newton second. This is the momentum, resultant momentum. Now just equate the momentum of third part is equals to resultant momentum. So what will you get? Resultant momentum is 20. and the momentum of third part m into v. So m is equals to how much? 20 upon 4. So I will get 5 kg. Option D. Clear? Next, 1 kg stationary bomb, that means its initial velocity is 0. So initial momentum of the system is also 0. Is exploded into 3 parts having mass 1:1:3 respectively. The parts having same mass move in perpendicular direction with the velocity 30 meter per second. The velocity of the bigger part. See, initially 0. So initial momentum of the system 0. That means the final momentum of the system also has to be 0. It was exploded into 3 parts. That means P1 plus P2 plus P3 must be equal to 0. It was said first one and second one, which are having the same mass. They are moving in perpendicular direction. 1:1:3, right? This is the ratio of the masses. So we'll do one thing. First part 1 kg. Second part 1 kg. They are moving in perpendicular direction with how much velocity? 30 meter per second. 30 meter per second. So where will be the third part now? It's the same model now. The total summation of momentum have to be 0. So the third part will be exactly in opposite direction to the resultant of these two parts. This is the resultant momentum. How much is this? First part momentum m into v, 30 into 1, 30 Newton second, 30 into 1, so 30 Newton second. So this is 30 square plus 30 square. This is equal, no? So if equal vectors are at 90 degrees, what is the resultant directly? It is vector root 2, or else you can do under root of 30 square plus 30 square. That is also fine. But if values are equal, we have studied in vectors, right? If values are equal, what is the resultant? Vector root 2. So 30 root 2. Now the resultant momentum should be equal to momentum of the third part. So this is 30 root 2. What is the momentum of the third part? M into V. So velocity of the bigger part, we have to find its velocity. But what is the mass? 1:1:3. So its mass is 3 kg. So M into V. So what is V now? So 30 root 2 upon 3. So you'll get 10 root 2 meter per second. Option A. Clear? Any difficulty? One more question. A mass of 1 kg is thrown up with a velocity 100 meter per second. So this is a body, mass 1 kg. It is thrown up, and what is the initial velocity? It is 100 meter per second. After 5 seconds, that means it was traveling for how much time? It was traveling for 5 seconds of time. After 5 seconds, now this is exploding into 2 parts. First part mass is 400 grams and it is coming down with the velocity 25 meter per second. After 5 seconds, explosion took place. The first part mass is 400 grams and that is coming down with velocity 25. What is the velocity of the other part? So what will be the other part? So the total mass is 1 kg, that means 1000 grams. So if first part is 400 grams, what is the second part? It is 600 grams. How it will move? How will it move? Upward or downward? Generally it should be in upward, because to conserve the momentum. If not, you will know it from the problem also. When you solve it, you will understand. So what is its speed? We don't know. That is a question mark. So we'll do one thing. The mass is exploding after traveling for 5 seconds. So if I ask you the initial momentum of the whole system, will you take 1 kg into u? Will you take 1 into 100? That would be wrong. What did I tell you? Momentum of the system before a process and after a process. What is the process here? Explosion is the process. So before the explosion, what is the velocity? That will be the initial velocity. This is the 100 meters per second. This is the initial velocity for projecting upward. But in order to take the conservation of linear momentum, what we have to consider? We have to consider momentum before a process and after a process. So you have to take before explosion and after explosion. So before explosion, what is the velocity? How will you find it out? So first find it out using this kinematics equation. V is equals to U plus AT. We don't know V. Initial velocity is 100. And what is acceleration here? It's nothing but G value. G will be always downward, so minus 10. And time is how much? 5 seconds. So simplify this. So 100 minus 50. So I will get 50 meter per second. So this is the velocity before the explosion. So what is the initial momentum of the system now? It is mass, which is 1 kg, into velocity, which is 50. So initial momentum of the system is 50 Newton second. Keep it as 1. What is the final momentum of the system? P final of the system. There are two parts now. So take their summation. First part 400 grams. So 400 by 1000 M into V plus M into V. We don't know this V. And what is the direction of the first part? It is moving downward. So velocity direction is downward. So it will be negative. We have studied, right, sign convention in kinematics. Vector in downward direction, you have to take it negative. Okay. Second part we don't know, so just take it the same. Now this is your final momentum of the system. Now according to conservation of linear momentum, both have to be equal. So just equate 1 equal to 2. So what will you get? Anything gets cancelled here. 2 zeros cancel. 2 zeros cancel. 2 3s 6, 2 5s 10. 2 2s 4, 2 5s 10. Okay. Now 5 1s, 5 5s 25. So initial momentum is 50 and final momentum, if you see 5 into 2, it's minus 10. Plus, what will you get here? What will you get? It's 3 upon 5. 3 by 5 V. Now 3 by 5 V is equals to 50 plus 10, 60. So what is V now? It is 60 into 5 upon 3. So just simplify this. 3 one time, 3 20 times. So 20 into 5, this is 100. So 100 meter per second. Now what is the sign of the answer that you got? You got positive answer, right? That means the second part is moving upward. Second part is moving upward. So what is the velocity of the other part? 100 meter per second. And what is its direction? Its direction is upward. Clear with this? What you have to remember here is always initial momentum is before a process. So before process, what is the velocity? That you have to consider for initial momentum. Okay. There you have to be a bit careful. We'll do few more questions. A shell in the flight explodes into 4 unequal parts. Which of the following is conserved? See, generally in explosion, what remains constant? What remains conserved? Linear momentum, right? So answer is option B. Next, a body of mass 5 kg explodes at rest. That means initially body is at rest. That means initial velocity is 0. Initial momentum of the system is also 0. That means the final momentum of the system also has to be 0. And what is the mass? It is 5 kg. 3 fragments with the masses in the ratio 1:1:3. The fragments with equal masses fly in mutually perpendicular directions with the speed of 21. Question is repeated now. Just data is different. Moving in perpendicular direction. Equal masses 1 kg, 1 kg. Perpendicular directions. What is the speed? 21 meter per second. 21 meter per second. So where will be the resultant of these two? The resultant of these two will be here. They are at 90 degrees. What is the momentum of the first part? M into V, so 21 Newton second. Momentum of the second part, M into V, so 21 Newton second. So what will be the resultant momentum now? Equal and at 90 degrees. So vector root 2. So 21 root 2 Newton second. This is the resultant momentum. The velocity of the heaviest fragment. Heaviest fragment is with the mass 3 kg. So what will be the direction of this 3 kg mass? So it will be exactly opposite to the resultant. So this is the direction of third part. Its mass is 3 kg. We have to find its velocity. Same concept. The resultant momentum will be equal to momentum of the third part. So momentum of the third part is how much? M into V. What is the resultant momentum? 21 root 2. So what is V now? It is 21 root 2 upon 3. So 3 7 times, right? So 7 root 2 meter per second. Answer is option A. Clear? Very easy. See, you can see how many times this question is, this model of question is being asked. So practice it thoroughly. Okay. Next, a shell of mass m at rest initially. That means initial velocity 0, initial momentum of the system 0. That means according to conservation of momentum, final momentum of the system also has to be 0. Exploding into 3 fragments in the ratio 2:2:1. Fine. Fragments having equal masses fly along mutually perpendicular directions with the speed v. We have to find the speed of the third part. Same model. Do it fatafat. So 2 kg v meter per second. This is 2 kg equal masses moving with the speed v meter per second. What will be the resultant of them? Resultant momentum. And exactly opposite is the third part motion. So third part is the lighter part. So that means 1 kg mass. You have to find its speed. What is the resultant momentum here? First part momentum m into v, 2v. M into v, 2v. So what is the resultant? Equal and at 90 degrees. So vector root 2. This is the resultant momentum. Now just equate. Momentum of the third part is equals to resultant momentum. So it is m into v. V and v will confuse, no? So just take it as v3. So v3 is equals to 2v root 2. So what is v3 now? 2v root 2. 1 even if it is present or absent doesn't make difference. So 2v root 2 meter per second. So answer is option B. 2v root 2, 2v root 2. B and C, they look the same, no? They look same. So we'll do one thing. We'll make a small change. We'll take it as 2 root 2 whole v. What is our answer? 2v root 2. So we'll take option C as the answer now. 2 into v into root 2 separate. Okay. Maybe print error. Recoil of the gun. See, this is also based on conservation of linear momentum. Conservation of linear momentum. I think we have discussed one problem. The force exerted on the person, the velocity of the person, it's the same thing. So just imagine firing a gun. Okay, so bullets are ejected out of the gun. See, before firing, what you have to consider here, before a process and after a process. So before firing and after firing. So before firing, after firing, before a process and after a process. What remains the same? Tell me. What remains the same? Momentum remains the same. So momentum before firing and momentum after firing will remain the same. So before firing, this is the gun and this is your bullet. Consider this as first object, consider this as second object. Both objects are at rest. So before firing, gun momentum 0, bullet momentum 0. After firing, let these be the mass of bullet. V1 be the speed of the bullet. Gun mass, let it be M2. Speed, let it be V2. So after firing, what happens? Bullet moves forward. But what is a jerk direction? It is in backward direction. So the gun moves back with some velocity. So this backward velocity is called recoil velocity of the gun. So it moves backward, right? It faces some jerk in the backward direction, right? So this is called recoil velocity of the gun. Got my point? So after firing, bullet is moving forward. So what is its momentum? M1 V1. Gun is moving backward. What is its momentum? M2 V2. But it is in backward. So it will be M2 into minus V2. So M1 V1 minus M2 V2. Now what happens? M1 V1 will be equal to M2 V2. So remember this. So whenever it comes the concept of recoil of the gun, momentum of the bullet will be equal to momentum of the gun, because initially the whole system momentum is 0. So final momentum also has to be 0, and this is possible if the two objects move in opposite direction. Their momentums must be in opposite direction. So M1 V1 must be equal to M2 V2. Remember this. Done? We'll do one problem. After that we'll wind up the class. A man fires a bullet of mass 200 grams. So bullet mass, what is the mass? 200 grams. At a speed, what is the speed of the bullet? Let it be V1, 5 meter per second. The gun is of 1 kg mass. So what is the mass of the gun? Let it be M2, it is 1 kg. By what velocity the gun rebounds backward? That means it experiences a jerk. What is that velocity they are asking? So as I told you, recoil of the gun. So what will you consider here? M1 V1 is equals to M2 V2. So 200, it is in grams. So divide by 1000 into V1 5. M2 is 1 kg, V2 we don't know. So V2 will be what? What gets cancelled here? 2 zeros cancel. 5 one time, 5 two times, 2 one time, 2 one time. So nothing is left, so 1. So 1 meter per second. So what is the velocity of the gun now? It is 1 meter per second in backward direction. Answer is option number A. Clear? Just think once what we have discussed in today's class. We have understood the concept of conservation of linear momentum and how it applies to different types of problems, especially collisions. We also practiced previous year NEET questions, which gives you a clear idea of the exam pattern and some important question types also. As I told you that two fragments moving perpendicularly, what should be the mass of the third part or velocity of the third part, such kind of questions. So make sure you revise the formulas, practice more questions and try to analyze where you might make some mistakes. Okay, and rectify your mistakes, practice more. If you find this session helpful, don't forget to like, share and subscribe to the channel for more concept based and exam oriented classes. Thank you for watching and I'll see you in the next class.